All right, I'm gonna do exercise 67, creating a squeeze bottle from the Rhino level 1 manual. I won't do from all the way to the end because it shows how to do, like, for example, the helix for the filleting, for the bottle filleting. Okay, so I don't think I need to do everything. There's at the very end part of that exercise, it says modeling the screw thread part 1, and you just click on the link, and it's going to show you the tutorial on how to do the screw threads. Okay, part 1 and part 2. Okay, so I'm going to go all the way up to that level. Okay, it's pretty much step by step. So just download the manual or already get it. Maybe you already have it. And so exercise 67, basically it's asking you to open the squeeze bottle.3dm, okay, which is what I did. So I have here the file. I turned on the bottle curves. So I think it shows up like this. You just turn on the bottle curves and it shows you already the 4 curves that are already prepared for the tutorial, okay. So I just want to talk to you before I start doing the tutorial. I promised you that I would show you once I extend the curve toolbar that to explain you a bit better the difference between the control point curve and the curve interpolate points. So let me go, for example, in the front view, and let me draw a rectangle that is very similar to the example that we see here. Okay, I'm just gonna maybe change layers. So you see, here I've got the main layer. Simply by clicking new layer, you create the main layer. And underneath, you can create sub layers. So by clicking here, you just click, so you select the main layer and you click on sub layers, and it's going to create a new layer underneath the bottle curves layer. So I'm just going to call it, I don't know, rectangle demo, for example. And I'm going to activate this. I'm going to select this and drop it into the rectangle demo there, like that. Okay, so you can see here a curve that follows basically the proportions that are set with this rectangle. And you can use it not only to set the proportions, but also as a drawing aid when you draw the shape of a rectangle. So, for example, when I use the control point curve and I activate near my snapping toolbar, and I can go and grab, for example, I'm going to replicate more or less the same shape here. So I'm going to snap in near here, and I'm going to press shift and just place the second point about here, and then I just change direction like this, and then I snap to my rectangle, and it goes like that, and I keep on snapping in near, and I go like this very quickly. There you go. So let's say I've got something more or less similar. You can see that it follows nicely the rectangle, and then I turn like that. So a tool that I recommend you get familiar with, if I go into my analyze direction and extend the toolbar, so the analyze toolbar, and you've got here curvature graphon. Sometimes we call it the porcupine. So if you click on the curvature graphon, and I select that curve, and you can see the curvature graph appearing. This is the curve here, so I can change the color to white, like that. And you can see more or less the shape of my curve, how it behaves. So I can play with the scale, and I can play with the density of my comb, okay? In no way by playing with these values you're modifying your curve. It's just for visual purposes. You can increase the scale just so that you can see a bit better how your curvature is progressing from point to point along that curve. Okay, so by using the first set, the control point curve, I can snap to that rectangle easily and follow and create the shape that I want just by snapping in near. I'm going to show you the difference. Now let me erase this curve, and I'm going to show you the difference with interpolate points, what happens. I'm just going to click on that, snap in near like I did here. I'm going to press shift, place the second point, and then I'm going to start changing direction like this, and then immediately I start seeing something weird happening. And I keep on snapping near, and I just change direction, and I keep on clicking like this, and I can see something wrong happening. You can see these waves, so I can select my curve, activate my curvature graph on, and you can see a lot of zigzags. Okay, if I take this curve and I do the same thing, it's nice and progressive. Yes, the transition here, it's a, let's say it's a negative curvature. Let me redo it. Let's say that this is a negative curvature and this is a positive curvature. You can see that the comb lines are transitioning from negative to positive. Then it's positive, positive, and then when it snaps to a straight line, it becomes perfectly neutral, so you don't see anything. But in this case, it stops here, okay? But if you were to draw a straight line, for example, let me demonstrate this for you. Let's say I take a straight line and I do the curvature graph on. Obviously, nothing happens because it's just a straight line. It's only visible when you see deflection in your curve. So, for example, this is a nice example of how the curvature is behaving from point to point along that curve. Okay, and it's going to be much bigger here because it's a sharper turn. So that's why you see such a big comb line. Okay. So that's basically understanding how the curvature behaves. And of course, if I were to analyze this and I see all these little zigzags, that means I've got very subtle changes in the direction, and it's going to be reflected once you start creating a surface out of it. It's going to be visible, and that's how you end up with dense, something that makes irregular looking surfaces, because you can see that it's a poor quality curve. And I'm going to show you in future exercises how to create quality curvature 2D lines so that you can end up with nice quality surfaces. So you're going to use a lot the curvature graph on. But right now for this exercise, you don't need to use this. I just wanted to show it to you and explain to you basically the difference between these two. Also, the other thing I want to mention, and I already mentioned, I know that, but if I were to create multiple points like this, because sometimes, I don't know, I could get data from an engineer who would give me a set of points for an aircraft wing. I would just get it as a set of points. Well, obviously, I won't use the the control point curve instead. I won't use the control point curve, but I will use instead the interpolate points. Since I've got data that comes as a set of points, then I can snap in the point on my toolbar, and then I can snap from point to point, and now my curve goes through these points. It has to go through these points, okay? And that's simply by choosing interpolate points. That's the only way that I can have this curve going through these points. Because if I were to use the first icon, which is control point curve, and I snap to point, you can see the result. It's not at all what I want, okay? So I want you to understand basically the difference between the two, when to use it, you know. These are the main lines. So in this case, with the rectangle, I won't use the interpolate points, but instead the control point curve. And most of the times I like to draw, and I hope you noticed in the past exercises, most of the time I use the control point curve function to work with to create my curves. Okay, it gives a nice tension, and that's I would advise you work with this most of the time. All right. Now let's go back to the exercise. So once I've got my set of curves that are already created, and that I'm pretty sure you already know how to do that. It's pretty straightforward. So it's basically this profile curve here is connected to the quad of that ellipse here, and it's connected to the quad of that ellipse over there. Okay. So now I have to do what we call a sweep to rail. So I can go and choose it here, sweep to rails, and select my first rail, my second rail, and then my section, and I just press enter. So it's giving me a preview, so I'm just going to click OK. If close sweep is unchecked, let's see. Okay, sometimes it might happen that it doesn't do a full clean sweep, that it completely closes. So you can check close sweep and click OK, and it's going to make sure that it's closing everything. Okay. I'm sure I'm going to show you other demos when I need to check the close sweep function. All right, so now I've got this curve, and I want to create a surface out of it. So I know I can go here and use surface from planar curves, and select that curve and press enter. So I've got that surface. Now I've got one edge here and another edge here, right? So I can use the blend surface function. So I just do blend surface, which is here, blend surface, and I select the edge, press enter, and I select the other edge, and I can see here my arrows. They're not perfectly aligned, they're going in the same direction. So what I'm going to do is activate my quad snapping toolbar, left click on this arrow and just drag it until I grab the quad of my ellipse like that. So now I'm properly aligned, so I will avoid any twisting effect, and I just right click again. I can click on preview. So now I've got curvature continuity in 1 and 2, and I can play with my handles to define the shape that I want for my bottle. Okay, so let's say something like that, and I just click OK. So now I'm going to join this together, and there you have it. Okay, so next, what do they want? Let me see. So we've done this, we've done the sweep, we've done the blend, and then I need to cap it. So there are different ways of capping it. So I can, since I've got a poly surface with one open end here, I can do solid cap planar holes like that. Okay, or I can click undo, and I can go here and select surface from planar curve. So I can select either the edge or the curve, but I like to select the edge, and I press enter. And now I click join like this and this one, and automatically it says two surfaces or poly surfaces join into one closed poly surface. So I've got a nice solid. Okay, next step. That's done. So flatten the sides. Okay, so I have to activate a layer. So change to the default layer in the front viewport. Draw the two lines. I see. So I'm gonna have to draw lines, a group of lines. So I'm gonna go into the front viewport, and I'm gonna draw first line. Okay, I'm gonna click on project for now. And I'm going to snap to the quad, and I'm just going to draw a first line like this. I'm going to activate my gumball, and I just want to pull it a bit up like that. Okay. So there's my line, smack in the center on my x-axis. Okay. So I've got this line. I'm going to make a copy of that line. So I can go and click copy. And what does it say? It says, just a sec. So I need to make a copy, and then I need to move the center line a bit more forward, it seems. Yeah, and make sure that the lines extend a little below and above the height of the bottle. That's important, okay? So I'm going to create this surface, and then you have to loft this. So I'm going to loft these three curves that I'm going to create. So the center curve will be a bit more forward than these two curves. And I'm going to loft this so that I can generate this surface to use it as a trimming. Okay, so let's go back to my work. So I've got my curve that is extending beyond the height and the bottom of my bottle. That's fine. And I'm just going to make a copy, and I'm going to move this other curve about here, like this. And then I'm going to make a mirror. So I select that curve, and I choose mirror. I can snap to the end of my curve here, and there you have it. So I've got my three curves. Now I need to move them forward, so I'm going to select those three curves. It's kind of hard to see. Maybe in the right view it's going to be a bit better. I can switch to ghosted mode if I want, and I just need to move them, let's say about, I don't know, something like that, I guess. And what I'm going to do is take this middle curve, and I need to move it a bit more forward as well. So I select it, and I click on move, and I just need to move it, I don't know, let's see, like this. Let me compare it with the, okay, something like that, I guess. All right. Doesn't have to be exactly like the tutorial. It's just that you understand the principle. Okay, so I've got my three curves, 1, 2, and 3 here. And then I just go here and I select the loft function, and I select curve 1, 2, and 3, and I press enter. And there you have it. Okay, I'm going to cancel it because I want to re-emphasize that you need to click in the same region. Okay, look what happens if I don't do it. If I go and do loft again, and I select the first curve here, and then I click down here, and then I go back here, and I press enter, and you see a twisting effect happening right now. Okay, so you don't want that, obviously, so I'm just going to cancel. I redo loft, and I select in the same region. If you click here for the first curve, make sure the second and the third you click in the same region, and I press enter, and now you're gonna avoid the twisting effect. So I leave it at normal, do not simplify, and I click OK. Alright, so I've got that, and I'm gonna select that surface, and I'm just gonna make a mirror. I'm gonna switch to the right view. I know that the bottle is centered at 0, so I just press 0 for the mirror, and I send a copy on the other side. So here's the result. So now I need to do a trim. So let me see. Sorry, let me see. So yeah, he's gonna do a mirror change. Okay, he's doing a Boolean difference. Okay, he's not gonna do a trim. I'm gonna explain the difference between the two. So the Boolean difference is gonna save you one step. So let's say I do a Boolean difference. I've got a solid here, enter, and I've got a surface here, I press enter, and it does the difference. So I repeat, Boolean difference, I select my bottle first, it's a solid, I press enter, and I select my surface and I press enter. And there you have it. Alright, before I show you the other with the trim function, I want to explain also the importance of the normals direction. Remember when I told you when you click, so let's say I select that surface and I click on normal direction, on analyze direction I mean, the normals are pointing in this direction and it worked the Boolean difference. If I left click to change the direction of my surface, so to change the direction of my normals on that surface, okay, so now I just change it. Look what happens when I do a Boolean difference. I do Boolean difference between that solid, enter, and that surface, enter. And now you get a result that is completely, well, that it gives you a result that's not what you expected, okay? So again, I want to re-emphasize, whenever you have surfaces and you do a Boolean difference, make sure that, you know, if you get an unexpected result when you're doing a Boolean difference, it's very likely because your normals are not pointing in the right direction. So I just need to click on Analyze Direction here, and I just left click and then right click, and I've changed the direction so that now when I do a Boolean difference, I select my solid, enter, and I can select both surfaces also at the same time and then enter, and there you have it. Okay, it did the difference. When I do a trim, this is what happens. So I do trim. I can do trim if I want, okay? So I can select this surface and that surface. These are my cutting objects. I press enter. And what part I want to get rid of, it's this one, here and here, okay? But look what happens when I trimmed it. If I delete these two surfaces, I get holes, okay? It's going to create holes. So the Boolean difference did something, saved you one step, you know. In this case, I would have had to create another surface. In this case, it's not a planar curve, so I won't be able to use the planar curve. Maybe patch would have worked. So if I click on patch and I select the edge, I press enter. So let's say I don't want the tangent C and I keep it at 10 and 10 in U and V. Let's keep stiffness at 1. I can click preview and it gives you this result, okay? It's probably not exactly the same result as doing with the Boolean difference, but it, you know, if that's what you want, you know, and it works for you, that's fine. You can use that. And in this case, I can join these two surfaces together, and there you go. Okay. So remember, there are some certain functions that, you know, when you trim, you come back to a open poly surface in this case, or if I were to do a Boolean difference, I remain into a solid, so a closed poly surface. So my bottle is a closed poly surface. I just do Boolean difference, select my solid, enter, 1, select my two surfaces, and do, whoops, now I've made a mistake. I didn't check my normal, so I'm just going to click here, left click, enter, make sure that, okay, that this one seems to be okay. So let's do another time. Boolean difference, let's choose the solid, enter, surface 1, surface 2, and there you have it. Okay. Now, what's next? I've done the difference. Okay, they want to do this. I think you can do it yourselves. I don't need to show that. You pretty much, you just draw a set of lines at 0.125 distance, and then you go down, and then you create an arc, and so on. And you just snap to the midpoint of the bottom part of your drawing, and you just snap to the quad of your bottle, and you just do a revolve, and there you have it. Okay, the bottle's complete. Okay, so I'll let you do this exercise. I wanted to show you the differences between the Boolean difference and the trim function, and also explain. I wanted to make it clear the difference also between the control point curve and the interpolate points. So please do exercise 67 by yourselves. Do the threads as well. So their videos are inside the manual. You just go all the way at the bottom at the end of the exercise, and it's modeling the screw thread part 1 and part 2, and it's going to take you directly on how to do those screw threads. Okay, that's it. Thank you.